Hey everybody, Brian here from quantlabs.net. Over the last few months, I put up a survey, and some of the highlights that came out of it. The video was called, posted April 14th. What truly is risk in trading whatever asset class you choose? A very interesting comment came in a day ago, right here. The first one is the stop loss hunting practice tactics are so common now that I've noticed most people are using virtual stop losses, even if they're manually trading. So we've talked about that in like videos like this where virtual stop losses cannot be tracked by the broker. So now we came about another comment here from Infinite Universe 88. What about bonds? You briefly mentioned treasury bonds, but don't include them on your list. I'm particularly interested in first world countries that have interest rates higher than many third world countries. Portugal. Moreover, I code in Java. It's not as efficient as C++, but it's quicker to code because it's more conceptual language, and the time saved in creating the code with Java is worth more than the efficiency gained with less memory with optimized C++ in most cases. Okay, so let's talk about the first part here about interest rates and bonds. One of my courses that I talk about, which is really to give you a solid foundation in trading overall, is to watch the futures and options market. So this course here is built off of a course that you can get for free from Davis University or whatnot out of California, which is open source and free. I provide some of the source code for both in Java and C++. One of the things that I want you to pay really particular attention to, which I do plan, and I do have the code to watch different asset classes, specifically interest rates as one factor that will impact overall markets at a more granular level, be it or micro level at the exchanges. So one of the things here, I could go on about this for a long time, but I would obviously include treasury bonds as one of the areas to watch, specifically yield curve as a way to measure if there's going to be any forecasting recessionary conditions. Another big area that I've seen is the cost of carry model and the interest rate parity, which is very important because from learning on Bloomberg, what I'm finding is where you get the biggest swings is in headline news, and these pretty well are some of the classic examples of that cost carry model and interest rate parity. So one of the good examples of interest rate parity is where pensions and hedge funds pretty well are going to invest in countries that offer a higher interest rate, but usually at a higher probability of, or closer or a higher probability of default. Like Greece is an extreme example, and you can definitely arbitrage the difference between those two countries that issue those type of interest rates. I've already talked about the yield curve as another one, and on it goes. We could talk about purchasing power parity, which is inflation, blah, blah, blah. And this course is awesome if you want to learn that and understand UC Davis, because I've been following this for about 3-4 years now, and with some predictability, you can build automation around it. And it opens up a large percentage of, or should I say, a higher set of opportunities for trading at a much more predictable and higher swings as it comes out. A good example I was just mentioning last Monday was the Taiwanese market and the Taiwan dollar, which last week sometime over the previous month was the best performing forex currency out there, and that was foreseen a month prior, because why? If you watch the money flow into Taiwan via ETFs or futures or other product, you can see that, and that's headline news. And that is money moving into Taiwan for the better performance that you'll get elsewhere. And it's usually the best performance you'll get globally. So, yes, I do watch this stuff. The other big thing that you need to be aware of is if you go to my YouTube channel, and let's say, I know I have something like over 1,500 videos, but I've done Fed analysis, so this is just as a hint. This is as a hint for anybody who may be interested in these topics. If you look and just do a search on Fed anything, you'll see the amount of analysis that I've done over the last set of years. And it's really, really staggering what you'll find where the Fed is trying to hide data sets. I mentioned that last week in another video. So I do plan to watch this. Very important stuff because it will drive hints at what's really going on in the economy that even media outlets won't see. And this is what the professionals use, but they won't talk about it. But because I have such a vast community, I'm being told what to look for. And when I look at it myself for that deeper understanding of that research, it's pretty staggering what I find. Okay, so let's talk more about this Java versus C++ business. In the same video here, you'll notice I do analysis, or I did a survey on what people use in terms of languages for both analysis as well as live trading. And what I'm finding is obviously for analysis, without a doubt, I don't care what anyone says, it's Python by far. 40-something% of people use it. And number two, which is quite far back, is C++. That's what the industry uses, hedge funds, investment banks, so on and so forth, where they use C++ with C as well. And that's important to note. Now, in terms of efficiency, you may be right on the Java in terms of convenience of the coding. I tend to agree on that, but if you looked at more recent versions of C++, it's becoming closer to closer to Java as well as C#, and it has some of its own set of standards that are blazing the next generation of languages and other updates in other languages. So modern C++, which is what it's called, is much better to develop with, and it's actually smarter and more efficient coding with modern C++, meaning using 14 and even 17, and it's quite interesting what they're coming about with over the last few years. It's getting more convenient, so I'll just leave it at that. Conditions in the markets are constantly changing. An algorithm that worked yesterday might not work tomorrow. Absolutely true. A lot of people don't know this, but there's Jim Simmons, who has obviously probably the world's best trader, best hedge fund guy. In my early days, I mentioned this, I don't mention this a lot, but the guy that funded Jim Simmons follows what I do because he's a venture capitalist. He's got his own operation, and apparently he's good friends with Jim Simmons as well. So he watches what I do. But what he told me back in the early day, before I was kind of a dodo in all this stuff because it was new to me, he told me is you want to have a large set of algorithms on at your disposal. It could be a couple hundred, thousand maybe. Every time the market changes, you're going to have a new algorithm that you'll be ready to deploy when you have another algorithm that's watching what the market's doing, and you're going to be running a slew of different simulations to be able to deploy the correct algorithm and be able to both get better analysis, and then when you do have more solid analysis, then you can basically do better trading and more accurate trading with a better, more positive outcome, meaning profit. So that's something that you need to consider. You cannot be in an operation with like only 10 algorithms or 20 algorithms. You need a large set. That's what I have with both Python and C++ and a little bit of Java. My approach to C++ and Python are very different from most people. I should say that. A lot of my analysis will be done in Python. I have ways to speed up Python immensely. That's through like Cython. Apparently it's come about in a large way. But what really strikes me about this, when you say an algorithm today may not work tomorrow, which is again true. There's a couple of things I can suggest that I've been looking into. Let me finish this off. The slower coding of C++ might not be able to keep up with a changing market in contrast. Java can allow one to more quickly adapt their strategy. Will be best to create multiple programs for different types of markets. I like to think of them as different personalities. And that's probably a good way of defining it. For instance, you can always deploy Python analysis very quickly because it's Python. You can do the equivalent of whatever language like C++, C, Java, even C#. You can do the equivalent of maybe, let's say, 100 lines and maybe 5 lines in Python. So that's why there's a huge movement towards Python because of that convenience. And of course, people say, well, you get how Python is very slow and deficient. I agree with that. But there's a couple of options that I'm looking at that I can suggest that I think will have better outcomes. For instance, if you come into my Redis, my playlist here, what you'll find here is if you go under Redis, the new Redis 4 is unbelievable. It's very innovative. And what I found with Redis 4 is when you combine, obviously, machine learning is a hot topic right now, and there's pretty well 3 libraries that are the leaders. And obviously, the Google TensorFlow is number 1, and then there's Theano, and then there's one that's not talked about a lot called Torch. For my analysis that I've been putting up is with Torch, which has pretty well been driven and popularized by both Twitter and Facebook. It is faster and it might not be as diverse, but it will offer you a better set of performance versus the other languages or the other libraries. So for instance, like TensorFlow is a big library. It's slow because it's in Python, and apparently you can do it in interface with C++, but from what I understand, it's not the standard practice. So there's not a lot of maturity and a lot of community behind that, but there is an option. Now, as I said, I mentioned Torch. Now, the nice thing about Redis and Redis 4 is there's a couple things. If you go to my blog, let's say, okay, let me open up another instance of this. Okay, so if you go into my blog and you look up Redis, you'll find all kinds of articles on Redis, specifically more of the recent ones over the last couple of weeks. So here is Redis with Lua, which is a really neat language, and it's embeddable inside of Redis. Now, the first thing I want you to understand is a lot of things here. This is pretty mind-blowing. When Redis 4 came out, there was something, a new library here, or a new call where you can do in a thread safe. You got to remember that Redis is single-threaded. This is why it's possible to do this. In a thread-safe context, you can now implement keys in a non-blocking, client-blocking module command. Okay, that's a huge revolutionary change when it comes to both NoSQL and databases overall. That's number one. Number two is with NoSQL, machine learning, and graph objects. These are the two big areas with machine learning that are built around it. So now, under the smart architecting from guys like the original founder, like Salvatore, who founded it, and is pretty well a lead guy behind the development of Redis, and it's true open source, not a freemium product. What he's done is he's taken your server product of Redis, again open source in C, and he's built these things called modules in Redis 4. It's a major feature of now new Redis 4 that enable you to have separate modules builded or built on top of the core server instance. So for instance, you can have, let's say, a module with a session or an instance of Redis running with a neural net, or even a cluster of that. And then on top of that, you can have graph objects as well, built on the same Redis server instance or cluster. Very ingenious way to build out large data sets and still be able to do fairly quick analysis on the data as you stream it in through a message queue. Okay, pretty very ingenious design. So again, the founders, Salvatore Filippo, and this is the other really interesting thing that brings in the new machine learning. Now, with the Redis Lua scripts that, again, are embeddable, right, embeddable into Redis, the instance, or Redis, the cluster. So what you can do is you can have scripts running on the database layer and be able to run processes right in the database itself as you stream data into it. That takes away a lot of latency. It takes a lot of extra layers and bloatware that you would bring in if you were to use something like Spark or any of the other, like Hadoop, or yet if you were to do this, try to do this in a live environment with Theano or TensorFlow, because of all that extra crap and libraries that you really don't need to run it. Whereas here, with these architecture of having the basic Redis core, the server, and then you can add on the modules as you want and have only those running in memory as part of the database cluster or server instance. So what that means is now you have kept it bare bones minimum, and now at the same time through a message queue you can add in your filters or your scripts using Lua embedded right in the database. This is very powerful. So what this means is, as an example, you can have data stream through your database cluster, any set, and then you can have Lua scripts running embedded in the database as part of that. And what I mean by that is then you can add in the Lua language, which I've been looking at, very powerful, very lightweight, and you can add in now your machine learning components, because now you have the ability to use Torch, because why? It's written in Lua, which that enables you to now have machine learning built into your Lua script, which again is embeddable into your Redis cluster. So you've now removed a lot of the extraneous garbage that you don't need that come with other big bloatware databases and libraries. Now, I need to remind you, this is all open source. This is not like Mongo freemium junk where you got to pay extra dollars to get in-memory data management with Mongo. This is 100% pure open source written in C with embeddable Lua. Okay, so I've been talking about this a lot, and I want everybody to understand that. Now, if you want to get even more crazy, you can build Lua, because why? Redis is an embeddable database. So it's so small, has such a small footprint, you can embed Redis right into devices that are really small. And then you can put those same devices onto flash memory. So now when Redis Labs, the cloud provider for Redis, did this as what they call the flash option, you can basically go from 1 million or 2 million transactions per second up to 4 million transactions per second. And let me remind you, this is all done in real time. This is not where you've got all these extra libraries and stuff running. This is done in Redis. Okay. Now, one other thing I've been looking at is this thing called Zero Brain. One of the biggest complaints with Lua is you can't debug it, because it's a scripting language, it's very difficult to do that. Well, Zero Brain, again open source, which is quite ingenious. The guys over at Redis Lab say, hey, why don't you have a module that you can build for Zero Brain and deploy it for Redis? So this debugger enables you to basically have a debugger in your, like, analyzing your Redis instances or cluster in real time and be able to run your Lua scripts on top of, while it's embedded in real time in your Redis cluster. This is pretty ingenious stuff. So here I mentioned the plugins. Let me just see the Redis one right here. Plugin to use current debugger API and blah blah blah. I could go on about it. Very interesting progress here. You don't get this with Java, even C++. It's done in C with Lua embedded in the script or in the database. So it takes away all the different abilities, because now you can have all these different Lua scripts written in Redis in real time and use them as an analysis script or an actual script that does analysis in the data embedded in the cluster, and have that trading logic right in the Redis database in real time, I might add. Okay, so if you still have no headaches from it, hopefully you understand what I'm trying to say here. Last paragraph. Perhaps what's most important, though, is an understanding of Bayesian math. That is new. That is new data is constantly affecting probability. The Monty Hall problem is the most well-known example of math. Indeed, it's Bayesian math more than anything which helps one understand why Java is a better programming language than C++ in most languages. Again, I'm not going to get into which is the better language here, but which may be more applicable to what you say here in your real-time analysis in a database. It is possible. In terms of Bayesian, I played with it. It looks kind of cool for machine learning. Maybe I might one day do a study on it with potential of how to apply it with the Torch, let's say, as well as Lua embedded in a Redis cluster. In actual fact, let me just do a search on that. So if I do Torch, which I've talked about, but let's see if I can find anything Bayesian. So here, Bayesian optimization in Torch 7. So the cool thing is, it's built on LuaJIT, which has been mentioned by a couple of people. I want to play with it, with this. This is a very interesting idea. I'm not sure if other people have come about it more intelligent, but I'd be very curious to see how and why and where with this combination. I've been trying to get a dialogue going with this, but I'd be very interested to hear from people about it. All right, so I just thought I'd put this out there because this is a very interesting topic, and my ideas where I'd like to take this. But if you got any ideas, let me know via comment here or my Facebook or whatever. I want to hear from you. All right, later.